Good afternoon, dear students. So today's physics class. So ನನ್ನ ಹೆಸರು ಭಾರ್ಗವ್ HG ಅಂತ, ಲೆಕ್ಚರರ್ ಇನ್ ಫಿಸಿಕ್ಸ್, ಗವರ್ಮೆಂಟ್ PU ಕಾಲೇಜ್, ಮೋತಿವೀರಪ್ಪ ಗವರ್ಮೆಂಟ್ PU ಕಾಲೇಜ್, ದಾವಣಗೆರೆ. ಸೊ ಇವತ್ತು ಮೈ ಟಾಪಿಕ್ ಈಸ್ electromagnetic waves. So electromagnetic waves, as you know, it is chapter number 8 in our second year syllabus. So the marks allotted is, the hours allotted is only 3 hours. Though it is a very small chapter, so it is having, I think, very good weightage ಇನ್ ನೀಟ್ ಅಂಡ್ CET ಮತ್ತೆ JEE ಎಕ್ಸಾಮ್. ಯಾಕಂದ್ರೆ ಅಟ್ ಲೀಸ್ಟ್ 1 or 2 ಕ್ವಶನ್ಸ್ ಅಂತೂ ಬರುತ್ತೆ. ಯಾಕಂದ್ರೆ ದ ಮಾರ್ಕ್ಸ್ ಟೀಚಿಂಗ್ ಅವರ್ಸ್ ಇಸ್ ಓನ್ಲಿ 3, ಬಟ್ ದ ಕ್ವಶನ್ಸ್ ಅಪಿಯರಿಂಗ್ ವಿಲ್ ಬಿ ಐದರ್ 1 or 2 ಕ್ವಶನ್ಸ್ ವಿಲ್ ಡೆಫಿನೆಟ್ಲಿ ಗೆಟ್. ಮತ್ತೆ ಇಟ್ ಈಸ್ ವೆರಿ ಸಿಂಪಲ್ ಚಾಪ್ಟರ್, ಯು ಕ್ಯಾನ್ ಗೆಟ್ all the questions right if you study it very well. So that small chapter but very great weightage. So the chapter is electromagnetic waves, chapter number 8. So as you know, the concept of electromagnetic waves, it starts with the concept of displacement current. What current it is? Displacement current. So I think you know what is displacement current as you have studied in the class. So it is displacement current. Displacement current. So what is displacement current? So this concept of displacement current, as you know, was introduced by Maxwell. So you have studied that when Maxwell was trying to study the magnetic field around a capacitor, which is being charged by time varying electric current. So he found some inconsistency in Ampere circuit law. So you know what is Ampere circuit law? So the line integral of total magnetic field B dot dl over a closed loop surface is equal to mu naught times the current enclosed. This is Ampere's circuit law as you have studied. But when this person Maxwell was trying to find the magnetic field around a capacitor plate which was charged by time varying electric current, so he found some inconsistency in the Ampere circuit law, that we call it as inconsistent Ampere circuit law. So as you know, when he uses a circular Amperian loop, he got the value mu naught I by 2 pi r. But when he uses a Tiffin box shaped, when you use a Tiffin box shaped Amperian loop, so the magnetic field was found to be zero around a capacitor which is being charged by time varying electric current. So if the Ampere circuit law was perfect, whatever may be the shape of the Amperian loop that we choose, whether we choose a circular Amperian loop or a Tiffin box shaped Amperian loop or a pot shaped Amperian loop, we should get the same value of the magnetic field. But when you choose a circular, it was mu naught I by 2 pi. But when you choose a pot shaped or Tiffin box shaped Amperian loop, the magnetic field around this capacitor was found to be zero. So our Maxwell he started thinking, so there is some thing wrong that has went in Ampere circuit law. He calls it as inconsistency. Inconsistency. So now we have to remove the inconsistency. He started so now we started thinking that there is something wrong. So he introduced the concept of displacement current. What current it is? Displacement current. So you know displacement current ID. Now the small letter use small big letter use. So displacement current ID, you know, it is equal to epsilon naught times d pi e by dt. D pi e by, so dt. So this is called displacement current. And the current is displacement current. So the current outside the capacitor plates. So the capacitor plate, the current outside the capacitor plates, we call it as conduction current. And the conduction current. So Maxwell he argues that in between the plates of a capacitor, the capacitor plate which is being charged by time varying electric field or time varying current. So there is another current which is calls it as displacement current. And the current displacement current. So he calls it as displacement current. So when he introduced the concept of displacement current, Maxwell, so Ampere circuit law holds very good, even if you change the shape of the Amperian loop. If you take a circular Amperian loop or a pot shaped Amperian loop or a Tiffin box shaped Amperian loop, you'll get the same value for the magnetic field when he introduced the concept of displacement current, which is in between the plates of a capacitor plates, which is being charged by time varying electric current, or time varying electric field. So what is displacement current? The current between the plates of a capacitor, which is charged by time varying electric field, is called as displacement current. The expression is ID, D for displacement, is equal to epsilon naught. You know what is epsilon naught per unit of free space? D pi E by dt. What is D pi E by dt? So pi is electric flux. So time varying electric flux d pi e by dt. So that is calls it as displacement current. He calls it as a displacement current. So this displacement current. Now we calls it as Ampere-Maxwell equation. So it was originally Amperian equation. Now it is called as Ampere's-Maxwell's equation. Ampere's-Maxwell circuit law. It was originally Ampere circuit law. So now it is called it as Ampere's-Maxwell circuit law. So this concept of displacement current, it makes the loss of electricity and magnetism more symmetric. ಯಾವಾಗ ಅವನು ಈ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ ನ ತರ್ತಾನೋ, the concept of displacement current makes the loss of electricity ಮತ್ತೆ magnetism more symmetric ಅಂತ ಹೇಳ್ತಾನೆ. So what is symmetric? You can look it in the textbook. So he calls it as more symmetric. So therefore, the other concept is whether this electric current is continuous. Electric current is continuous. ಹೌದಾ? So this electric current outside the capacitor plate, he calls it as conduction current. ಎಂತ ಕರೀತೀವಿ ಅದಕ್ಕೆ? Conduction current. The current in between the plates of the capacitor plates, he calls it a displacement current. What you call it as a displacement current. So if you take both conduction current and displacement current together, both will be continuous. Both will be continuous. But if you choose only conduction current or only a displacement current, they are not continuous. They are discontinuous. They are not discontinuous. They are discontinuous. ಯಾವಾಗ continue ಆಗುತ್ತೆ ಅಂದ್ರೆ when you choose both electric current ಅಥವಾ when you consider both conduction current as well as displacement current, then it will be continuous. But if you only choose the conduction current or if you only choose the displacement current in between the plates of a capacitor, then it becomes discontinuous. Then it becomes discontinuous. ಹೌದಾನೆ? So conduction current IC ಇದೆಯಲ್ಲ, the conduction current IC which is flowing outside the capacitor plate, it is continuous only outside. It is continuous only outside the capacitor plates. But once you enter the capacitor plates, it becomes discontinuous. It becomes discontinuous. ಯಾಕಂದ್ರೆ capacitor plate ನಡುವೆ ಯಾರು ಇರ್ತಾರೆ? There will be only displacement current. So in between the capacitor plates, the displacement current is continuous. Conduction current is discontinuous. But when you take both conduction current and displacement current together, so the concept becomes continuous. So the current is continuous when you choose both conduction current and the displacement current. Correct? The expression for displacement current, ID is equal to epsilon naught d pi e by dt. So after introducing this displacement current, the Ampere's Maxwell's circuit law can be written as line integral of B dot dl. Line integral of B dot dl will be equal to mu naught into IC. What is IC? Conduction current, which was originally thought by the Ampere. Then we have mu naught epsilon naught d pi e by dt. So this is called as Ampere's Maxwell's circuit law. Ampere's Maxwell's circuit law. So this is expression for Maxwell circuit law. So this last term was introduced by Maxwell when he introduced the concept of displacement current. What current? Displacement current. So after this, Maxwell started deriving some 5 set of equations. So they are called as Maxwell's equations. Maxwell's equation. So they are called as Maxwell's equation. So first equation, the line integral of E dot ds, that is equal to Q by epsilon naught. This is called as Gauss line magnetism. Gauss line electrostatics. So line integral of E dot ds is equal to Q by epsilon naught. The total electric flux over any closed loop surface is equal to 1 by epsilon naught times the total charge enclosed or the net charge enclosed. So it is called as Maxwell's first equation. Also, it is Gauss law in electrostatics. Gauss law in electrostatics. So by using this law, we can find the total electric flux. You can find the total electric flux over a closed loop surface. Surface. So this law states that the electric lines of force start from positive charge and end at negative charge. That is, the electric force lines of force do not form continuous closed loops. So this law states that, although this law says that the electric field lines are continuous closed loops. They do not form continuous closed loops. Second, they start from positive charge and they will terminate at negative charge. So they are not continuous. They are not continuous. They are continuous only where continuous only in a charge-free region. In a charge-free region, they are continuous. But if there is a charge, so they will terminate or originate. They originate from the positive charge or terminate at the negative charge. So this way is seen if you see the Gauss line electrostatics. The second Maxwell's equation is the Gauss law in magnetism. The Gauss law in magnetism, again, B dot ds. The line integral of B dot ds is equal to 0. So the total magnetic flux over any loop surface is equal to 0. So this is Gauss line magnetism, that is also called as Maxwell's second equation. Maxwell's second equation. So this law shows that number of magnetic field lines, force of the field lines in a closed surface is equal to number of force leaving the surface. ಅಂದ್ರೆ ಯಾವುದೇನು ಕ್ಲೋಸ್ ಸರ್ಫೇಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಂಟ್ರಿ ಆಗ್ತಾವೋ ಅಷ್ಟೇ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಶುಡ್ ಲೀವ್. ಅಷ್ಟೇ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಶುಡ್ ಲೀವ್. ಸೊ ದೇ ವಿಲ್ ನಾಟ್ ಟರ್ಮಿನೇಟ್, ಅಥವಾ ಎಲ್ಲವೂ ಟರ್ಮಿನೇಟ್ ಆಗಲ್ಲ ಅಥವಾ ಎಲ್ಲೂ ಒರಿಜಿನೇಟ್ ಆಗಲ್ಲ. ದ ನಂಬರ್ ಆಫ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಂಟ್ರಿಂಗ್ ಎ Gaussian surface will be equal to number of magnetic field lines leaving. So therefore the net magnetic flux becomes 0. Correct? So next ಹೇಳ್ತಾನೆ this magnetic field. So according to this Gauss line magnetism, the magnetic field lines, the called as magnetic field lines ಅಥವಾ magnetic lines of forces ಏನ್ ಬೇಕಾದ್ರೂ ಕರಿಬಹುದು. So they are continuous without any break. They are continuous without any break. ಅವೆಲ್ಲೂ ಟರ್ಮಿನೇಟ್ ಆಗಲ್ಲ ಅಥವಾ ಎಲ್ಲೂ ಆರಿಜಿನೇಟ್ ಆಗಲ್ಲ. They are continuous. ಯಾವುದು magnetic field lines. ಆಯ್ತಾ? So ಮತ್ತೆ ಹೇಳುತ್ತೆ this Gauss line magnetism says that magnetic monopoles cannot exist. ಎಲ್ಲೂ magnetic monopoles ಇರೋದಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ ಅಂತ ಹೇಳುತ್ತೆ, because RHS is 0. RHS is 0. So therefore magnetic monopoles do not exist ಅಂತ ಹೇಳುತ್ತೆ. The next Maxwell's equation, that is ಯಾವುದು Faraday's law. Faraday's law. The next Maxwell's equation is Faraday's law. So the Faraday's law of electromagnetic induction. What is Faraday's law of electromagnetic induction? The induced EMF is equal to time rate of change of magnetic flux. The induced EMF is equal to time rate of change of magnetic flux. So that induced EMF epsilon is equal to minus n into dIB by dt. So it is called Faraday's law of electromagnetic induction. It is also called as Maxwell's third equation. Maxwell's third equation. So this gives the relation between electric field ಮತ್ತೆ magnetic field, ಅಥವಾ electric flux ಮತ್ತೆ magnetic flux, electric field ಮತ್ತೆ magnetic flux, which is changing with respect to time. Correct? So the next fourth Maxwell's equation is that we have just seen, that is Ampere's Maxwell's equation. What equation? Ampere's Maxwell's equation. Correct? So this is about Maxwell's equation. This is about Maxwell's equation. So after looking at these equations, so Maxwell predicted the existence of electromagnetic waves. What waves? Electromagnetic waves. When he studied the Maxwell's equation, so all set of Maxwell's equation, he came to conclusion that there is a wave which is having both electric field as well as magnetic field, so which are vibrating perpendicular to each other and to the direction of the propagation. ಇದರ ಒಂದು ವೇವ್ ಇರಕ್ಕೆ ಸಾಧ್ಯ ಇದೆ ಅಂತ ಹೇಳ್ದ. So he calls it as electromagnetic waves. He predicted ಇದಿರ್ಬೋದು ಅಂತ ಹೇಳ್ದ. But later on, Hertz and J.C. Bose and Marconi, so they produce the electromagnetic waves in a laboratory. Correct? So there we are one problem. ನೋಡೋಣ. So problems are important in this chapter. Very simple problems. So mostly ಕಾಣುತ್ತಾ ಇದು. Figure shows a capacitor made of two circular plates. ನೋಡಿ ಇಲ್ಲಿ ಈ figure ಅಲ್ಲಿ we are having two capacitor plates. So these are circular capacitor plates. You can have a parallel plate capacitor. ನಮ್ಮ syllabus ಅಲ್ಲಿ ಇರೋದು. You can have a plate of any shape. So here we are having two circular parallel plates. They are constituting a capacitor. So the radius of each plate is 12 centimeter. What is the radius of each plate? It is 12 centimeter. The radius of each plate is 12 centimeter. And separated by 5 millimeter. So the distance between separation is 5 millimeter. 5 millimeter. This capacitor is being charged by an external source. ಯಾವುದು external source ಇಂದ ಇದನ್ನ ಕನೆಕ್ಟ್ ಮಾಡಿದಾನೆ. It is connected to a external source. The changing current is equal to 0.15 ampere. The conducting current is 0.15 ampere. 0.15 amperes. This question is calculate the capacitance. What is the capacitance of this parallel plate capacitor? What is the capacitance of this parallel plate capacitor? You know the capacitance of a parallel plate capacitor. What is the formula? C is equal to epsilon naught A by D. Epsilon naught A by D. So, epsilon naught is permitted as free space. It is 8.85 into 10 power of minus 12 into A. So, area of the plate. Since they are circular plates, we should substitute it as pi r square. Pi under 3.14. R is radius, that is 12 into 10 power of minus 2 whole square. Divided by D. D is the separation between the two plates. Separation between the two plates, what is the separation between the two plates? He has said it is 5 millimeters, so 5 into 10 power of minus 3 meter. 5 into 10 power of minus 3 meter. So other thing you should remember while attempting CET, JE or NEET is time is also very precious. ನೀನು ಎಷ್ಟು ಕಡಿಮೆ ಟೈಮಲ್ಲಿ ಜಾಸ್ತಿ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ, ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಇಂಪಾರ್ಟೆಂಟ್. ನನಗೆಲ್ಲ ಗೊತ್ತಿರುತ್ತೆ, ಟೈಮ್ ಸಾಕಾಗಲಿಲ್ಲ ಅಂದರೆ, ಸೊ ಇಟ್ ಈಸ್ ನೋ ಎಕ್ಸ್ಕ್ಯೂಸ್ ಫಾರ್ ದಟ್. ಸೊ ದೇರ್ ಫಾರ್ ಯು ಶುಡ್ ಆಲ್ಸೋ ಟ್ರೈ ಟು ಮೇಂಟೈನ್ ದ ಟೈಮ್. ಇಲ್ಲಿ ಅಂದ್ರೆ ಈ ತರ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ಬೇಕಾರೆ, ಸೊ ಯು ಕ್ಯಾನ್, ಯಾಕಂದ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಇಲ್ಲ, ಸೊ ವಿತೌಟ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಯು ಶುಡ್ ಸಾಲ್ವ್. ಯು ಕ್ಯಾನ್ ಮೇಕ್ ಸಮ್ ರಫ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್. ಸೊ ದಿಸ್ 8.85 ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಆಸ್ ರಫ್ಲಿ 9. ಅಂದ್ರೆ ನೀವು ಆಪ್ಷನ್ಸ್ ನೋಡ್ಬೇಕು. ಹಾಗಾದ್ರೆ ಮತ್ತೆ ಆಪ್ಷನ್ಸ್, ಇಫ್ ದ ನಂಬರ್ಸ್ ಆರ್ ವೆರಿ ಕ್ಲೋಸ್, ಯು ಕ್ಯಾನಾಟ್ ಟೇಕ್ ದ ಚಾನ್ಸ್. ಹಾಗಾದ್ರೆ ಒಂದು ನಂಬರ್ ಸ್ವಲ್ಪ ದೂರ ದೂರ ಇದ್ರೆ ಯು ಕ್ಯಾನ್ ಟೇಕ್ ದ ಚಾನ್ಸ್, ಯು ಕ್ಯಾನ್ ಮೇಕ್ ಎ ರಫ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್. 8.85 ಕ್ಯಾನ್ ರಿಟನ್ ಆಸ್ 9 into 10 power of minus 12. ಸೊ ದಿಸ್ 3.14 ನ 3 ಅಂತ ಕರೋಣ. ಸೊ 12 square is 144 ಡಿವೈಡ್ ಬೈ 5 into 10 power of minus 3. 5 into 10 power of minus 3. So you can cancel 5 ones are 5 twos are 10 cancel ಮಾಡ್ಬಿಡಿ. So 3 twos are 6 into 144. 144 ಇಲ್ಲಿ ಇದನ್ನು ಬಿಟ್ಟಿದ್ವಿ, 10 power of minus 4 you have left. So power comes out to be 10 power of minus 1. 10 power of minus 1. minus 1 ಬರ್ತಾ, ಇಲ್ಲಿ ಇದನ್ನು ಬಿಟ್ಟು minus 12 minus 16. minus 16 ಇಲ್ಲಿ minus ಅಂದ್ರೆ minus 13 ಆಗುತ್ತೆ. ಇಟ್ ವಿಲ್ 10 power of minus 13 ಆಯ್ತಾ. ಸೊ ನಾವು ಮಲ್ಟಿಪ್ಲೈ 6 into 144. 6 4 6 24 2 6 24 20 26. ಸೊ ಲೆಫ್ಟ್. ಸೊ 8 ಪಾಯಿಂಟ್ಸ್, ಇಟ್ ವಿಲ್ ಬಿ 864 into 10 power of minus 13. ಅದು ಇಲ್ಲಿ ಎಷ್ಟು ಬಂದಿದೆ? 80 into 10 power of minus 12 ಬಂದಿದೆ. ಸೊ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆಸ್ 86. ಇಲ್ಲಿ ಮೈನಸ್ ಹಾಕಿದ್ರೆ ಇಟ್ ವಿಲ್ ಬಿ 86 into 10 power of minus 3. So given answer is 80 into 80 into 10 power of minus 12. So you are getting a nearby value. So you can mark the correct option without calculator. Matte by saving the time, so you can do it. So you can make some rough calculation wherever it is possible. Wherever it is possible. Now he is asking for, again he is asking for rate of change of potential difference. Again, when these capacitor plates are being charged by the time varying electric field, again in what rate the potential is changing? At what rate the electric potential is changing? So you know I is equal to dq by dt. I is equal to dq by dt, correct? So the current flowing, I is equal to dq by dt, correct? So this q can be written as d by dt of q is c into v. C into v, charge, charge will be equal to capacitance multiplied by the potential. So since capacitance is constant, we can take it outside. So therefore I is equal to c into dv by dt. dv by dt. So this dv by dt is time rate of change of potential. ಅವನು ಅದನ್ನೇ ಕೇಳಿದಾನೆ. ಸೊ at what rate the potential difference across the plates is changing ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾನೆ. So therefore you can write dv by dt will be equal to I by c. I by c. So you know I has given it as 0.15 ampere. 0.15 ampere divided by c. Just we have found it is some 80 into 10 power of minus 12. 10 power of minus 12. So ಮತ್ತೆ you can make some rough calculation. ಆಯ್ತಾ. ಸೊ ದಿಸ್ ನ ಏನ್ ಮಾಡಿದ್ನ 0.15 divided by 80. ಇದನ್ನ 10 power of minus 12 if it goes to numerator, it becomes 10 power of plus 12. ಸೊ ಮತ್ತೆ ನೀನು ಮತ್ತೆ ಡಿವಿಷನ್ ಅದು ಇದು ಮಾಡ್ತಕ್ಕಂತ ಹೋದ್ರೆ ಇಟ್ ವಿಲ್ ಕಿಲ್ ಯುವರ್ ಟೈಮ್. ಸೊ ಇದನ್ನ ಏನ್ ಮಾಡೋಣ, ಇಲ್ಲಿ 10 power of 2 ತಗೊಂಡು 100 ತಗೊಂಡು ಇದು ಮೇಕ್ ಇಟ್ ಆಸ್ 15 ಅಥವಾ 3 ತಗೊಂಡು ಯು ಕ್ಯಾನ್ ಟೇಕ್ 10 power of 12 ಅಲ್ಲಿ 10 power of 3 ಈ ಕಡೆ ತಗೊಂಡ್ರೆ ಇಟ್ ವಿಲ್ 150 divided by 80. ನೆಕ್ಸ್ಟ್ ಉಳಿತು ಇಲ್ಲಿ 10 power of 10 power of 12 ಅಲ್ಲಿ ಟೇಕನ್ 10 power of 3, ಹೌದಾ. ಸೊ ದ ರಿಮೈನಿಂಗ್ ಥಿಂಗ್ ಇಸ್ 10 power of 9. ಸೊ ಇಲ್ಲಿ 0 0 ಕ್ಯಾನ್ಸಲ್. ಸೊ 8 1s 8 2s ಆಲ್ಮೋಸ್ಟ್ 2 into 10 power of 9. 10 power of 9. So dv by dt volt per second. Volt per second. So ಇಲ್ಲಿ ನೋಡಿ 2 almost 1.87 ಇದೆ. You have got 2. So that is a nearby value. You can mark it. So by saving time, either. So you can make some rough calculation. Correct. Next part B is asking, obtain the displacement current across the plates. ಅವೆರಡು ಪ್ಲೇಟ್ ಇದಾವಲ್ಲ, ದ ಕೆಪಾಸಿಟರ್ ಪ್ಲೇಟ್ಸ್, ಅವೆರಡು ನಡುವೆ ಎಷ್ಟು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ಇರುತ್ತೆ? ವಾಟ್ ಇಸ್ ದ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ಬಿಟ್ವೀನ್ ದ ಕೆಪಾಸಿಟರ್ ಪ್ಲೇಟ್ಸ್? What is the displacement current between the capacitor plates? You know, if you take both displacement current as well as conduction current, they are continuous. ಅಂದ್ರೆ ಹೊರಗಡೆ ಎಷ್ಟು ಕಂಡಕ್ಷನ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರುತ್ತೋ, ಇನ್ ಬಿಟ್ವೀನ್ ದ ಕೆಪಾಸಿಟರ್ ಪ್ಲೇಟ್ಸ್ ಅಷ್ಟೇ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ದಟ್ಸ್ ವೈ he has given the conduction current. How much is the conduction current? 0.15 ampere. ಸೊ ಆದ ಕಾರಣ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ಎಷ್ಟು ಇರುತ್ತೆ? ಇಟ್ ವಿಲ್ ಬೈ ಆಲ್ಸೋ 0.15 ಆಂಪಿಯರ್. ಆಯ್ತಾ. ಇಲ್ಲಿ ಹೊರಗಡೆ ಎಷ್ಟು ಕಂಡಕ್ಷನ್ ಕರೆಂಟ್ ಇರುತ್ತೋ 0.15 ಆಂಪಿಯರ್ ಇದೆ. ಸೊ ಒಳಗಡೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ಅಷ್ಟೇ ಇರುತ್ತೆ. ಸೊ ಬೋತ್ ಕಂಡಕ್ಷನ್ ಕರೆಂಟ್ ಅಂಡ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ಆರ್ equal when they are taken separated. So the next thing is Kirchhoff junction rule valid at each plate of the capacitor? ಹೌದಾ? ಸೊ ಕೆಪಾಸಿಟರ್ ಎರಡೂ ಪ್ಲೇಟ್ ಅಲ್ಲಿ ಕಿರ್ಚಾಫ್ ಜಂಕ್ಷನ್ ರೂಲ್. ಕಿರ್ಚಾಫ್ ಜಂಕ್ಷನ್ ರೂಲ್ ಕರೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಓದಿರ ಹೌದಾನೆ? ಸೊ ವಾಟ್ ಎ ಜಂಕ್ಷನ್ ಇನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಸರ್ಕ್ಯೂಟ್, the amount of current entering will be equal to amount of current leaving. So therefore ಅವನು ಹೇಳ್ತಾನೆ ಇಲ್ಲಿ ಕಿರ್ಚಾಫ್ ಜಂಕ್ಷನ್ ರೂಲ್ ವ್ಯಾಲಿಡ್ is when these two capacitor plates are charged by a source. So correct, the junction rule is valid. ಯಾಕಂದ್ರೆ ನೋಡಿ ಇಲ್ಲಿ ಎಷ್ಟು ಕಂಡಕ್ಷನ್ ಕರೆಂಟ್ ಬರುತ್ತೋ IC ಕೆಪಾಸಿಟರ್ ಪ್ಲೇಟ್ ನಡುವೆ ಒಳಗಡೆ ಅಷ್ಟೇ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ. ಅಥವಾ ಹೊರಗಡೆ ಇಟ್ ಈಸ್ ಕಂಡಕ್ಷನ್ ಕರೆಂಟ್, ಇನ್ಸೈಡ್ ದ ಪ್ಲೇಟ್ಸ್ ಆಫ್ ದ ಕೆಪಾಸಿಟರ್, ಇನ್ ಬಿಟ್ವೀನ್ ದ ಪ್ಲೇಟ್ಸ್ ಆಫ್ ದ ಕೆಪಾಸಿಟರ್ ಇಟ್ ಈಸ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್, ವಾಟ್ ಎವರ್ ಮೇ ಬಿ ದ ಕರೆಂಟ್. ಬಟ್ ಎಷ್ಟು ಕರೆಂಟ್ ಎಂಟ್ರಿ ಆಗ್ತಿದೆ ಅಷ್ಟೇ ಕರೆಂಟ್ ಫಸ್ಟ್ ಪ್ಲೇಟ್ ನ ಲೀವ್ ಆಗ್ತಾ ಇದೆ. ಇನ್ ದ ಸೇಮ್ ಮ್ಯಾನರ್ ಯು ಅಬ್ಸರ್ವ್ ಸೆಕೆಂಡ್ ಪ್ಲೇಟ್, ಆಯ್ತಾ? ಸೊ ಇಲ್ಲಿ ಎಷ್ಟು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ಈ ಪ್ಲೇಟ್ ಇಂದ ಎಂಟ್ರಿ ಆಗುತ್ತೋ ಅಷ್ಟೇ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ವಿಲ್ ಕಮ್ ಔಟ್ ಆಫ್ ದ ಪ್ಲೇಟ್ ನಂಬರ್ 2, come out of the plate number 2. So therefore Kirchhoff junction rule is valid. ಆಯ್ತಾ? ಯಾಕಂದ್ರೆ ಎಷ್ಟು ಕರೆಂಟ್ ಕಂಡಕ್ಷನ್ ಕರೆಂಟ್ ಎಂಟ್ರಿ ಆಗುತ್ತೋ ಅಷ್ಟೇ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ಪ್ಲೇಟ್ ಇಂದ ಲೀವ್ ಆಗುತ್ತೆ ಫಸ್ಟ್ ಪ್ಲೇಟ್ ಇಂದ. ಅದೇ ತರ ಸೆಕೆಂಡ್ ಪ್ಲೇಟ್ ಅಲ್ಲಿ ಎಷ್ಟು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್ ಎಂಟ್ರಿ ಆಗುತ್ತೋ ಅಷ್ಟೇ ಕಂಡಕ್ಷನ್ ಕರೆಂಟ್ ವಿಲ್ ಲೀವ್. ಸೊ therefore Kirchhoff junction rule is also valid. ಆಯ್ತಾ? ಸೊ Kirchhoff junction rule ಇಲ್ಲಿ ವ್ಯಾಲಿಡ್ ಆಗುತ್ತೆ. ಆಯ್ತಾ? ದ ನೆಕ್ಸ್ಟ್ ಥಿಂಗ್ is electromagnetic waves. ಇಲ್ಲಿವರೆಗೂ ನಾವು ಮಾತಾಡಿದ್ದೆ ಅದು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಕರೆಂಟ್. Now we shall talk of electromagnetic waves. So who predicted the existence of electromagnetic waves? Yaar predict ಮಾಡಿದ electromagnetic waves? It is Maxwell. By using his set of equations, he predicted the existence of electromagnetic waves. So who discovered electromagnetic waves? Hertz. And then J.C. Bose produced the electromagnetic waves of shorter wavelength in Kolkata. Then Marconi was able to transmit them through a very long distance. So therefore, the credit of discovery of radio goes to Marconi. So the next thing is electromagnetic waves. Electromagnetic waves. So electromagnetic waves are transverse waves. What type of wave they are? Transverse waves. Electromagnetic waves are transverse waves. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ both electric field ಮತ್ತೆ magnetic field are vibrating perpendicular to each other and to the direction of propagation. So that's why they are called as transverse waves. Electromagnetic waves are transverse waves. So how to represent the electromagnetic waves? ಹಾಗಾದ್ರೆ electromagnetic waves ನ ಹೆಂಗ್ represent ಮಾಡೋದು? ಯಾಕಂದ್ರೆ ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ learnt about the chapter waves. ಅಲ್ಲಿ we know how to represent a mechanical wave ಅಥವಾ sound wave. In the same manner, so we can represent the electromagnetic wave either by a sine function or a cos function. Sine function represent ಮಾಡಬಹುದು ಅಥವಾ cos function represent ಮಾಡಬಹುದು. So ಯಾಕಂದ್ರೆ electromagnetic wave ಅಲ್ಲಿ electric field ಇರುತ್ತೆ. There will be electric field as well as the magnetic field, so which are vibrating perpendicular to each other. So if you look at this diagram, the electromagnetic wave is propagating along z direction. It is z direction, so it is propagating along z direction. So it is x-axis, this is y-axis. So the electric field is vibrating along x-axis, the magnetic field is vibrating along z-axis. So therefore, since electric field is vibrating along x-axis, we should write it as Ex. ಎಂತ ಬರಬೇಕನ್ನ Ex. So the electric component of the electromagnetic wave, that is Ex, will be equal to E naught, amplitude of the maximum value of the electric field, into, we can take sine or cos. For our convenience, I'll take it as sine k. In which direction it is propagating? Since it is propagating along z direction, so we should write it as kz. We write it as kz minus omega t. Minus omega t. So this is how we can represent the electric component of the electromagnetic wave, in which the electric component is vibrating along x direction. So therefore Ex is equal to E naught sine kz minus omega t. So k is called as propagation constant ಅಥವಾ wave number. Then how to represent the magnetic field? How to represent the magnetic field inside electromagnetic wave? So we should observe in which direction the magnetic field is vibrating. Since the magnetic field is vibrating along y-axis, we should write it as By is equal to maximum value of the magnetic field B naught, again sine function, in which direction the electromagnetic wave is propagating, z direction, so kz minus omega t. So this is how we can represent the electromagnetic wave. Correct? So then we can represent the electromagnetic wave in different forms. ಬೇರೆ ಫಾರ್ಮುಲಾ ಅದನ್ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು. ಕರೆಕ್ಟಾ? ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, k can be written as 2pi by lambda. 2pi by lambda. So this can also be written as, this electromagnetic wave Ex can also be written as, Ex ಅಂತ ಬರೆಯೋದು, Ex is equal to E naught sine k can be written as 2pi by lambda z. Correct? Minus omega can be written as 2pi by t, capital T into t. into small t. Here you can take 2 pi common. 2 pi common ತೆಗೆಯೋದು ಅವಾಗ ಏನಾಗುತ್ತೆ Ex will be equal to the electric component of the electromagnetic wave will be equal to E naught sine, if you take 2 pi common, 2 pi into z by lambda minus 2 pi is taken common, so t small t by capital T. ಈ ತರನು ನೀನು ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಟಿಕ್ ವೇವ್ ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು. ಸೊ ಡಿಫರೆಂಟ್ ಫಾರ್ಮ್ಸ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಬಹುದು. ಯು ಕ್ಯಾನ್ ಟೇಕ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಟಿಕ್ ವೇವ್ಸ್ ಕ್ಯಾನ್ ರೆಪ್ರೆಸೆಂಟ್ ಇನ್ ಡಿಫರೆಂಟ್ ಫಾರ್ಮ್ಸ್. ಸೊ ಯು ಹ್ಯಾವ್ ಸೀನ್ ಇಟ್. ಯು ಹ್ಯಾವ್ seen it. So then what are the properties of the electromagnetic waves? Nature of the electromagnetic waves. Nature of the electromagnetic waves. Correct? So if you know the E naught ಮತ್ತೆ B naught, E naught and B naught. So you can write the relation C is equal to E naught by B naught. So this is one of the important equation you should remember. C andre the speed of the electromagnetic wave in vacuum at the free space will be equal to E naught by B naught. What is E naught? The maximum value of the electric component. B naught is the maximum value of the magnetic component. If you divide, you will get C. You will get C. Other than you have an expression for speed of the electromagnetic wave. C is equal to 1 divided by square root of epsilon naught into mu naught. Epsilon naught into mu naught. So this is expression for speed of the electromagnetic wave in free space. Free space. You know, mu naught is the permeability of free space. Epsilon naught is the permittivity of the free space. Okay. So these are some different formula we can have for electromagnetic waves. Electromagnetic waves. Then we have the energy. What is the energy in the electromagnetic wave? What is the energy in the electromagnetic wave? So electromagnetic wave ಎಷ್ಟು energy ಇರುತ್ತೆ? So electromagnetic wave energy is both in electric component as well as magnetic component. So energy in the electric component, E can be written as half epsilon naught E RMS square. So this is the amount of energy in the electric component of the electromagnetic wave. ಅದೇ ತರ you can have energy UB and the magnetic component of energy will be equal to half epsilon naught ಬದಲು you can write as 1 by mu naught BRMS square. BRMS square. So you know electromagnetic waves also impart momentum. So they carry both energy and momentum. So momentum will be equal to U by C. U on the total energy. Total energy can be written as half. So it will have the sum of both electric energy both as well as magnetic energy. So half common third it will be epsilon naught E RMS square plus BRMS square divided by mu naught. So this is the total energy. So the total energy divided by C will give you the momentum of the electromagnetic wave. Then what is the intensity? So 2I by C. 2I by C will give the pressure. Pressure in the electromagnetic wave. So electromagnetic waves carry both energy and momentum. So they will also impart pressure. That is called as radiation pressure. So it is then 2I by C, where I is called as the intensity of the electromagnetic wave. In the intensity of the electromagnetic waves. So then, you know, you are studied in the class what are the different types of electromagnetic waves, how to produce the electromagnetic waves. They are produced by some klystron. ಎಲ್ಲ ಇದೆ. ಸೊ ನೋಡ್ಬೋದನ್ನ. ಸೊ ವಿ ಕ್ಯಾನ್ ನೌ ಗೋ ಫಾರ್ ದ ಪ್ರಾಬ್ಲಮ್ಸ್ ದಟ್ ಆರ್ ಸಾಲ್ವ್ಡ್ ಇನ್ ಅವರ್ ಸಕ್ಷಮ ಬುಕ್. ಕಾಣ್ತಾ ಇದೆ ಮೋಸ್ಟ್ಲಿ ಇದು. ಫಸ್ಟ್ ಕ್ವಶನ್. All components of electromagnetic spectrum in vacuum have the same electromagnetic wave. You know that the electromagnetic spectrum, you have long range of electromagnetic spectrum. So from radio waves in the from radio waves, microwaves, infrared waves, next to visible light ಆದ್ಮೇಲೆ ಮತ್ತೆ ultraviolet ಆಯ್ತಾ. ಸೊ ಈ ತರ ಅಪ್ ಟು ಗಾಮಾ ರೇಸ್, ಎಕ್ಸ್ ರೇಸ್, ಮತ್ತೆ ಕೊನೆಗೆ ಗಾಮಾ ರೇಸ್. ಸೊ ಇಟ್ ಇಸ್ ದ ಲಾಂಗ್ wavelength of electromagnetic waves. So I think you know we are dipped in the sea of electromagnetic waves. ಎಲ್ಲರೂ electromagnetic wave ನ ಒಂದು ಸಮುದ್ರದಲ್ಲಿ ಮುಳುಗೋಗ್ಬಿಟ್ಟಿದ್ದೀವಿ. ಸೊ we are dipped. ನೀವು ನನ್ನ ಕ್ಲಾಸ್ ಕೇಳ್ತಾ ಇದ್ರೆ ಅಥವಾ ಯು ಆರ್ ಅಬ್ಸರ್ವಿಂಗ್ ಮೀ ಬಿಕಾಸ್ ಆಫ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಟಿಕ್ ವೇವ್ಸ್ ಓನ್ಲಿ. ಹೌದಾನೆ? ಅಕಸ್ಮಾತ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಟಿಕ್ ವೇವ್ಸ್ ಇಲ್ಲ ಇದ್ರೆ ಸಕ್ಷಮನೂ ಆಗ್ತಾ ಇಲ್ಲ, ಯಾವ್ದು ಆಗ್ತಾ ಇಲ್ಲ. ಸೊ ಯು ಶುಡ್ ಬಿ ವೆರಿ ಥ್ಯಾಂಕ್ಫುಲ್ ಟು ದಿಸ್ ಚಾಪ್ಟರ್ electromagnetic waves. ಆಯ್ತಾ? ಸೊ ಅವ್ನು ಕೇಳ್ತಾ ಇದ್ದಾನೆ ಆಲ್ ಕಾಂಪೊನೆಂಟ್ಸ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಟಿಕ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಇನ್ ವ್ಯಾಕ್ಯೂಮ್ ಯಾವ ದ ಸೇಮ್. ಸೊ ಎಲ್ಲಾ ಕಾಂಪೊನೆಂಟ್ಸ್ ಅಲ್ಲೂ ಏನ್ ಸೇಮ್ ಇರುತ್ತೆ ಇನ್ ಕೇಸ್ ಆಫ್ ವ್ಯಾಕ್ಯೂಮ್? ವಾಟ್ ಈಸ್ ದ ಥಿಂಗ್ಸ್ ದಟ್ ಈಸ್ ಸೇಮ್? ಎನರ್ಜಿ ಸೇಮ್ ಇರುತ್ತಾ? ಇಲ್ಲ. ಯಾಕಂದ್ರೆ ಏನೋ electromagnetic wave, energy of a electromagnetic wave will be E is equal to h mu. These electromagnetic waves are having different frequency, so therefore they are having different energy. Which part of the electromagnetic wave is having the highest energy? Which is having highest energy? Gamma rays. Which is having the least energy? Radio waves. ಯಾಕೆ ಅದಕ್ಕೆ highest energy ಅಂದ್ರೆ because of highest frequency. So therefore ಎಲ್ಲ ಕಾಂಪೊನೆಂಟ್ ಅಲ್ಲೂ ಎನರ್ಜಿ ಸೇಮ್ ಇರಲ್ಲ, ಎನರ್ಜಿ ವಿಲ್ ಬಿ ಡಿಫರೆಂಟ್. ಸೊ ದೇರ್ ಫೋರ್ ದಿಸ್ ಇಸ್ ನಾಟ್ ದ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. ಅವ್ನು ಕೇಳ್ತಾರೆ ಅದರಲ್ಲಿ ಏನ್ ಸೇಮ್ ಇದೆ ಅಂತ. ಆಲ್ ಕಾಂಪೊನೆಂಟ್ಸ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಟಿಕ್ ಸ್ಪೆಕ್ಟ್ರಮ್ ಇನ್ ವ್ಯಾಕ್ಯೂಮ್ ಯಾವ್ದು ಸೇಮ್, ಎನರ್ಜಿ ಇರಲ್ಲ, ಎನರ್ಜಿ ವಿಲ್ ನಾಟ್ ಬಿ ಸೇಮ್. ಎಷ್ಟು ವೆಲಾಸಿಟಿ ಸೇಮ್ ಇರುತ್ತಾ? ವೆದರ್ ಆಲ್ ದ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಟಿಕ್ ವೇವ್ಸ್ ಆರ್ ಮೂವಿಂಗ್ ವಿತ್ ದ ಸೇಮ್ ವೆಲಾಸಿಟಿ ಇನ್ ವ್ಯಾಕ್ಯೂಮ್. ಕರೆಕ್ಟ್ ಆಯ್ತಾ? they are moving the same speed. ಎಷ್ಟು 3 into 10 power of 8 meter per second. So ಇಷ್ಟು ಸ್ಪೀಡ್ ಅಲ್ಲಿ all electromagnetic waves are moving in a vacuum. So therefore there is radio wave, microwave, IR, visible, they are all moving at the same speed. So therefore all the components, ಯಾವ component same ಇರುತ್ತೆ ಅಂದ್ರೆ velocity will be same. Velocity will be same. So this is the correct option. So wavelength same ಇರುತ್ತಾ? ಇಲ್ಲ. wavelength ಹೌದಾ? So as you move from radio waves to gamma rays, wavelength will decrease. Wavelength will decrease. Frequency will increase. Frequency ಜಾಸ್ತಿ ಆಗುತ್ತೆ, wavelength ಕಡಿಮೆ ಆಗುತ್ತೆ. as you move from radio to gamma rays, energy ಏನಾಗುತ್ತೆ? Energy will also increase. Wavelength change ಆಗುತ್ತೆ, frequency will increase. So the correct option is option 2. So the thing that is common, I mean that is same for all electromagnetic spectrum, all the waves in the electromagnetic spectrum is velocity. Velocity remains same. Next question number 2. If mu naught is the permeability of free space, you know mu naught is permeability of free space. What is the value of mu naught? Mu naught value ಗೊತ್ತಾ? Mu naught. What is the value of mu naught? 4 pi into 10 power of minus 7. Correct? So if mu naught is the permeability of free space and epsilon naught is the permittivity of free space. Epsilon naught is the permittivity of free space. ಇದು value ಆಗಲಿ ನೋಡಿ 8.85. The speed of light in vacuum is, ಅಗರ್ vacuum ಅಲ್ಲಿ ಎಷ್ಟು ಸ್ಪೀಡ್ ಇರುತ್ತೆ? So we have already seen. The correct option is, what is the speed of electromagnetic waves in vacuum ಅಥವಾ in free space in terms of mu naught ಮತ್ತು epsilon naught? Option is 1. Correct. First option is correct. ಯಾಕಂದ್ರೆ C is equal to 1 divided by mu naught epsilon naught square root. Square root of mu naught ಮತ್ತೆ epsilon naught ಅಂತ ಬರ್ದಿ. So option is 1. So ಇದನ್ನ ಮೇಲ್ಗಡೆ ಹಾಕ್ಬೋದು, put it. This can also be done as 1 divided by mu epsilon ಅಂತ ಹಾಕ್ಬೋದು. This can also be written. ಎಲ್ಲಿದು? This is the speed of electromagnetic wave in some medium V of permittivity epsilon and permeability. ಇದು free space ಅಲ್ಲಿ. This equation is when the electromagnetic wave travels through some medium, just like water ಅಥವಾ glass, what will be its speed? V is equal to 1 divided by square root of mu into epsilon, where mu is the permeability of that medium, that is water ಅಥವಾ glass. Epsilon is the permittivity of that medium, water or glass. So this is the correct option is option 1. So therefore the speed of light in vacuum is given by C is equal to 1 divided by epsilon naught mu naught square root. That's why this can also be written as 1 divided by square root of mu naught epsilon. ಈ ತರ ಬರೆಯಬಹುದು. So option 1 is correct. Option 1 is correct. So this chapter ನೀವು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿದಾಗ again you can get easily 2 ಅಥವಾ 1 question correctly. So ಬಹಳ ಕಷ್ಟ ಇಲ್ಲ, you can do it. So the next question. Which of the following statement does not hold good for thermal radiation? Thermal radiation ಗೆ ಯಾವ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇದರಲ್ಲಿ ಕರೆಕ್ಟ್ ಹೋಲ್ಡ್ ಆಗಲ್ಲ? Which is the thermal radiation? IR, infrared radiation is called as thermal radiation. It is also called as heat wave. ಎಂತ ಕರಿತೀವಿ ಅದಕ್ಕೆ? Heat wave. ಯಾಕಂದ್ರೆ ಏನೇ ನಮ್ದು ಹೀಟಿಂಗ್ ಎಫೆಕ್ಟ್ ಎಲ್ಲ ಆಗುತ್ತೆ ಅರ್ಥ ಮೇಲೆ, ಅದು ಎಲ್ಲ ಕಡೆ ರೆಸ್ಪಾನ್ಸಿಬಲ್ part of the electromagnetic spectrum is infrared radiation. Which radiation? Infrared radiation. So one question, which of the following statement does not hold good for thermal radiation? ಇಲ್ಲಿ thermal radiation ಯಾವುದು ಹೋಲ್ಡ್ ಆಗಲ್ಲ ಕರೆಕ್ಟ್ ಆಗಿ ಅಂದ್ರೆ ರಾಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಯಾವುದು ಅಂತ ಕೇಳಿದೆ. The wavelength changes when it travels from one medium to another medium. Correct? Whether the wavelength of the electromagnetic wave changes when we move from one medium to another medium? Correct. It is correct. Statement is correct. ಅವನು ಕೇಳ್ತಾ ಇರೋದು ಹೋಲ್ಡ್ ಆಗಲ್ಲ ಅಂತ. The frequency changes when it travels from one medium to another medium. Whether the frequency of the electromagnetic wave changes when it moves from one medium to another medium. Say you are having a glass. ಏನಿದೆ ಇದು? Glass medium. Say you are having a UV ಅಥವಾ red light ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. Red color light. ಯಾಕಂದ್ರೆ I'm using a red color pen. So red color light is also electromagnetic wave. But when it moves from air to glass, its velocity will change. Velocity will change. Correspondingly, there is change in wavelength. Wavelength will also change, but frequency remains constant. Frequency change ಆಗಲ್ಲ. So ಅವನು ಹೇಳ್ತೇನೆ the frequency changes ಅಂತ ಹೇಳ್ತೇನೆ. So this is wrong statement. ನೋಡೋಣ. The speed changes when it travels from one medium to another medium. Correct. The velocity of the electromagnetic wave changes when it moves from one medium to another medium. So this statement is also correct. they travel in straight line in a given medium. So go to electromagnetic waves. So light travels in a straight medium. So ಮೂರು ಸ್ಟೇಟ್ಮೆಂಟ್ ಕರೆಕ್ಟ್ ಇದೆ. ದ ರಾಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ಸೆಕೆಂಡ್ ಒನ್. ದ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಈಸ್ ಸೆಕೆಂಡ್ ಒನ್. ಆಯ್ತಾ? ನಾನು ಕೇಳ್ತಾ ಇರೋದು ಡಸ್ ನಾಟ್ ಹೋಲ್ಡ್ ಗುಡ್ ಅಂದ್ರೆ ಇದರಲ್ಲಿ ರಾಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಹುಡುಕಿ ಅಂತ ಕೇಳ್ತೇನೆ. ದ ರಾಂಗ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಸೊ ದಟ್ ಇಸ್ ದ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್. Statement is wrong, but the option is correct. So the frequency changes when it travels from one medium to another medium. Frequency of the electromagnetic wave does not change. ಅದು medium ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಲ್ಲ. ಉಳಿದೆಲ್ಲ ಚೇಂಜ್ ಆಗುತ್ತೆ. Velocity will change, the wavelength will change. Correct? They move in straight lines, but frequency remains same. So the correct option is second. That is the wrong statement. Next question. ನೋಡಿ. Electromagnetic wave consists of periodically oscillating electric and magnetic vectors. Correct? In electromagnetic wave, we are having periodically oscillating electric and magnetic vectors. So electric vectors ಮತ್ತೆ magnetic vectors are periodically oscillating, just like a sine wave or cos wave. Correct? So if it is z-axis, say it is x-axis, it is y-axis. So say if the electric field is varying along x direction, this is the variation of electric field Ex. So ಇದು perpendicular ಆಗಿ ಮತ್ತೆ to the direction of propagation, there is a magnetic field which is also vibrating. So this we call it as By. This is the propagation. Our question ಏನು? Electromagnetic wave consists of periodically oscillating electric and magnetic vectors. Correct. It is consisting of periodically varying electric ಮತ್ತೆ magnetic vectors. ನೋಡ. Our question. ಹಾಗಾದ್ರೆ ಆ ವೆಕ್ಟರ್ಸ್ ಏನಾಗಿದೆ ಅಂತ? In mutually perpendicular planes but vibrating with the phase difference of pi. ಇದು PL actually, ಇದು pi ಆಗಬೇಕಿದು. This should be pi. ಅಂದ್ರೆ ಎರಡರದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಮತ್ತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ದೇ ಆರ್ ವೈಬ್ರೇಟಿಂಗ್ ಮ್ಯೂಚುವಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್. ಕರೆಕ್ಟ್. ದೇ ಆರ್ ವೈಬ್ರೇಟಿಂಗ್ ಮ್ಯೂಚುವಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್. ಒಂದು ಎಕ್ಸ್ ಎಕ್ಸ್ ಅಲ್ಲಿ ಇದೆ, ಇನ್ನೊಂದು ವೈ ಎಕ್ಸ್ ಅಲ್ಲಿ ಇದೆ. ಮ್ಯೂಚುವಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಪ್ಲೇನ್ಸ್ ಬಟ್ ವೈಬ್ರೇಟಿಂಗ್ ವಿತ್ ಎ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಆಫ್ ಪೈ ಅಂತ ಹೇಳ್ತಾರೆ. ಬಟ್ ದ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಮತ್ತೆ ವೈ ಆಕ್ಸಿಸ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಪೈ, ಇಟ್ ಈಸ್ ಪೈ ಬೈ ಟು. ಎಷ್ಟಿದು? ಪೈ ಬೈ ಟು. ಸೊ ದೇರ್ ಫಾರ್ ದಿಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಈಸ್ ರಾಂಗ್. ಸೆಕೆಂಡ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ನೋಡೋಣ. ಇನ್ ಮ್ಯೂಚುವಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಪ್ಲೇನ್ಸ್. ಕರೆಕ್ಟ್. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಮತ್ತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಆರ್ vibrating in mutually perpendicular plane, vibrating with a phase difference of pi by 2. Correct? Na? The phase difference between electric field and magnetic field is pi by 2. So this statement is correct. Third statement ಹೇಳ್ತಾನೆ in randomly oriented planes but vibrating in phase. ಯಾವ್ದು ಬೇಕೋ ಆ ಪ್ಲೇನ್ ವೈಬ್ರೇಟ್ ಆಗ್ತದೆ ಅಂತಿಲ್ಲ. ರಾಂಗ್. They should vibrate in planes which are mutually perpendicular to each other. So that's why randomly they cannot orient. So this is wrong statement. In mutually perpendicular planes, correct, but vibrating in phase. Wrong. They are not vibrating in phase. They are vibrating with a phase difference of pi by 2. So the correct option is option 2 is correct. So that is the correct statement. That is the correct statement. Next question. X-rays, gamma rays and microwaves traveling in vacuum have. You are having a X-ray, gamma ray and microwaves traveling in a vacuum. They are traveling in a vacuum. ಏನಿರುತ್ತೆ ಅಂತ? ಸೇಮ್ ವೇವ್ ಲೆಂತ್ ಬಟ್ ಡಿಫ್ರೆಂಟ್ ವೆಲಾಸಿಟಿ. ಎರಡಕ್ಕೂ ಸೇಮ್ ವೇವ್ ಲೆಂತ್ ಮತ್ತೆ ಡಿಫ್ರೆಂಟ್ ವೆಲಾಸಿಟಿ ಇರುತ್ತಾ? ಫಸ್ಟ್ ಆಪ್ಷನ್ ಕೊಟ್ಟಿದ್ದಾನೆ. ಸೇಮ್ ವೇವ್ ಲೆಂತ್ ಬಟ್ ಡಿಫ್ರೆಂಟ್ ವೆಲಾಸಿಟಿ. ಮೂರಕ್ಕೂ ಸೇಮ್ ವೇವ್ ಲೆಂತ್ ಇರುತ್ತಾ? ರಾಂಗ್. ವೇವ್ ಲೆಂತ್ ಆಫ್ ಎಕ್ಸ್-ರೇಸ್ ಇಸ್ ಡಿಫ್ರೆಂಟ್ ಫ್ರಮ್ ವೇವ್ ಲೆಂತ್ ಆಫ್ ಗಾಮಾ ರೇಸ್, ದಟ್ ಇಸ್ ಡಿಫ್ರೆಂಟ್ ಫ್ರಮ್ ವೇವ್ ಲೆಂತ್ ಆಫ್ ಮೈಕ್ರೋವೇವ್ಸ್. ಸೊ ದೇ ಕೆನಾಟ್ ಹ್ಯಾವ್ ಸೇಮ್ ವೇವ್ ಲೆಂತ್. ದೇ ಕೆನಾಟ್ ಹ್ಯಾವ್ ಸೇಮ್ ವೇವ್ ಲೆಂತ್ಸ್. ಡಿಫ್ರೆಂಟ್ ವೆಲಾಸಿಟಿ ಇಲ್ಲ. ಎಲ್ಲಿ? ವ್ಯಾಕ್ಯೂಮ್ ಅಲ್ಲಿ ಆಲ್ ದ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್ಸ್ ಆರ್ ಟ್ರಾವೆಲಿಂಗ್ ವಿತ್ ಸೇಮ್ ವೆಲಾಸಿಟಿ. ಸೊ ದೇರ್ ಫಾರ್ ವೆಲಾಸಿಟಿ ಇಸ್ ಆಲ್ಸೋ ಸೇಮ್ but different wavelengths. So first statement is wrong. Second ಹೇಳ್ತೇನೆ same frequency but different velocities. X-rayಗೂ gamma raysಗೂ ಮತ್ತು microwaves same frequency ಇದೆಯಾ? Whether they are having the same frequency? No. Frequency is different. ಯಾಕಂದ್ರೆ as you move from ಯಾವುದು ರೇಡಿಯೋ ವೇವ್ಸ್ ಇಂದ ನೀನು ಎಲ್ಲಿ ಹೋಗ್ತೀಯಾ ಕೊನೆಗೆ, ಫ್ರಮ್ ರೇಡಿಯೋ ವೇವ್ಸ್ ಟು gamma rays frequency increases. So therefore they cannot have same frequency but different velocity ಇಲ್ಲ. Velocity same ಇರುತ್ತೆ in vacuum. ಸೇಮ್ ವೆಲಾಸಿಟಿ ಬಟ್ ಡಿಫ್ರೆಂಟ್ ವೇವ್ ಲೆಂತ್. ಸ್ಟೇಟ್ಮೆಂಟ್ 3 ಹೇಳ್ತೇನೆ. ಈಗ ಎಕ್ಸ್-ರೇಸ್ಗೂ ಗಾಮಾ ರೇಸ್ಗೂ ಮತ್ತು ಮೈಕ್ರೋವೇವ್ಸ್ಗೂ ಒಂದೇ ವೆಲಾಸಿಟಿ ಇರುತ್ತೆ ವ್ಯಾಕ್ಯೂಮ್ ಅಲ್ಲಿ. ಕರೆಕ್ಟ್. ದೇ ಆರ್ ಟ್ರಾವೆಲಿಂಗ್ ವಿತ್ ದ ಸೇಮ್ ವೆಲಾಸಿಟಿ ಬಟ್ ಡಿಫ್ರೆಂಟ್ ವೇವ್ ಲೆಂತ್. ಕರೆಕ್ಟ್. ವೇವ್ ಲೆಂತ್ಸ್ ಆರ್ ಡಿಫ್ರೆಂಟ್. ಯಾಕಂದ್ರೆ ಇಫ್ ಯು ಮೂವ್ ಫ್ರಮ್ ರೇಡಿಯೋ ವೇವ್ಸ್ ಟು ಯಾವುದು ಲಾಸ್ಟ್ ಒನ್ ಗಾಮಾ ರೇಸ್, ವೇವ್ ಲೆಂತ್ ವಿಲ್ ಡಿಕ್ರೀಸ್. ಸೊ ದೇರ್ ಫಾರ್ ಡಿಫ್ರೆಂಟ್ ವೇವ್ ಲೆಂತ್ ಮತ್ತೆ same velocity. So option 3 is correct. Third option is correct. ನೋಡೋಣ ಫೋರ್ತ್ ಆಪ್ಷನ್ ಇದೆ ನೋಡೋಣ. then ಒಂದೇ ಸಲ ಡಿಸಿಷನ್ ಬರೋಣ ನೋಡೋಣ. What is the fourth option? Same velocity, correct, same velocity, and same frequency, that is wrong. So therefore, option 3 is correct. So these X-rays, gamma rays, and microwaves are traveling in vacuum will have same velocity but different wavelength. So the third option is correct. Third option is correct. So we shall now go for the fourth question. ನೋಡಿ. A charged particle, ಯಾವ ಒಂದು charged particle ಇದೆ with velocity 2 into 10 power of 3 meter per second. That charged particle is moving with a velocity of 2 into 10 power of 3. It is moving with a velocity of v is equal to 2 into 10 power of 3 meter per second. So ಇಷ್ಟು velocity travel ಆಗ್ತಾ ಇದೆ that charged particle. It is moving with a velocity of 2 into 10 power of 3 meter per second. Passes undeflected through electric field and magnetic fields in mutually perpendicular directions. ಈ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಎಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅಲ್ಲಿ ಬೋತ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದೆ ಮತ್ತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇದೆ. ದೇ ಆರ್ ಮ್ಯೂಚುಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ಈಚ್ ಅದರ್. ಸೊ ಅದರಲ್ಲಿ ಈ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ವೆನ್ ಇಟ್ ಎಂಟರ್ಸ್ ಇಟ್ ಮೂವ್ಸ್ ಅನ್ಡಿಫ್ಲೆಕ್ಟೆಡ್. ಡಿಫ್ಲೆಕ್ಟ್ ಆಗದಂಗೆ ಹೋಗ್ಬಿಡ್ತು. ಇಟ್ ಮೂವ್ಸ್ ಅನ್ಡಿಫ್ಲೆಕ್ಟೆಡ್. ನಿಮ್ಗೆ ಗೊತ್ತು ಯಾವಾಗ ಅನ್ಡಿಫ್ಲೆಕ್ಟ್ ಆಗುತ್ತೆ? ಒಂದು ಥೀಟಾ ಇಸ್ 0 ಡಿಗ್ರಿ ಆರ್ 180 ಡಿಗ್ರಿ. ಮೂವಿಂಗ್ ಚಾರ್ಜ್ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಲ್ಲಿ ಕಲ್ತಿದ್ದಾರೆ ಆಯ್ತಾ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಈಸ್ 1.5 ಟೆಸ್ಲಾ. ಸೊ ಈ ರೀಜನ್ ಅಲ್ಲಿ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಬಿ ಈಸ್ 1.5 ಟೆಸ್ಲಾ ಇದೆ ಅಂತ ಹೇಳ್ತೇನೆ. ಇಟ್ 1.5 ಟೆಸ್ಲಾ. ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ವಿಲ್ ಬಿ. ಹಾಗಾದ್ರೆ ಆ ರೀಜನ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟಿದೆ? ಇಗೂ ಬಿಗೂ ವಿಗೂ ವೆಲಾಸಿಟಿ ಅಥವಾ ಸಿಗೂ ಏನಿದೆ ರಿಲೇಷನ್? ಯು ಕ್ಯಾನ್ ರಿಮೆಂಬರ್ ದ ರಿಲೇಷನ್. ವಾಟ್ ಇಸ್ ದ ರಿಲೇಷನ್? ವಿ ನೋ ಸಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ಇ ನಾಟ್ ಬೈ ಬಿ ನಾಟ್. ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದಿಸ್ ರಿಲೇಷನ್. ಇ ನಾಟ್ ಬೈ ಬಿ ನಾಟ್. ಯು ಕ್ಯಾನ್ ಡೂ ಇಟ್. ಸಾಲ್ವ್ ಮಾಡಿ ನೋಡೋಣ. ಸಿ ಈಸ್ ಈಕ್ವಲ್ ಟು ಇ ನಾಟ್ ಬೈ ಬಿ ನಾಟ್. ವಿ ಹ್ಯಾವ್ ಟು ಹ್ಯಾವ್ ಇ. ಸೊ ದೇರ್ ಫಾರ್ ಇ ಈಸ್ ಈಕ್ವಲ್ ಟು ಅದು ಇ ನಾಟ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ಬಿ ನಾಟ್ ಇಂಟು ಸಿ. B naught into C. B naught is the maximum amplitude of the magnetic field. So B naught, how much is B naught? Yes, given. B naught is 1.5 Tesla. SI Newton is nodi, correct, 1.5 into C. C badlo. Since it is traveling in some medium, the velocity is it is larger particle. It is not the 2 into 10 power of 3. So V is 2 into 10 power of 3 meter per second. So 1.5 double model, it will be 3 into 10 power of 3 meter per second. So this is the correct option. 3 into 10 power of 3 meter per, Newton per coulomb. So not the velocity. It's asking for the electric field. So what is the unit for electric field? Newton per coulomb. So option 3 is 3 into 10 power of 3 Newton per coulomb. Correct. The next question. Read the question properly. Correct question ಓದ್ಬೇಕಾ? You should answer ಮಾಡಬೇಕಂದ್ರೆ you should read the question properly. ಅವಾಗ ಮಾತ್ರ you can answer. Otherwise ನೀವು ಸುಮ್ಮನೆ ಓದಿದ್ರೆ ಆಗಲ್ಲ. A plane electromagnetic wave of frequency 20 megahertz. You are having a plane electromagnetic wave of frequency 20 megahertz. Frequency is given, it is 20 megahertz. Mega andre 10 power of 6 hertz. It is the frequency of the electromagnetic wave. Traveling through a space. ಯಾವ ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇದೆ? Along x direction. So it is traveling along x direction. If the electric field vector at certain point in the space is 6 volt per meter, ಎಲ್ಲೋ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟಿದೆ? 6 ವೋಲ್ಟ್ ಪರ್ ಮೀಟರ್ ಅಷ್ಟು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇದೆ. ವಾಟ್ ಇಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವೆಕ್ಟರ್ ಅಟ್ ದಟ್ ಪಾಯಿಂಟ್ಸ್? ಮತ್ತೆ ಮಾಡ್ತೀವಿ. ವಾಟ್ ಇಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವೆಕ್ಟರ್? ಬಿ ಎಷ್ಟು? ಹೌ ಮಚ್ ಇಸ್ ಬಿ? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವೆಕ್ಟರ್ ಎಷ್ಟಿದೆ? ಕರೆಕ್ಟಾ? ಅಗೇನ್ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ದ ಸೇಮ್ ಫಾರ್ಮುಲಾ. ಏನು? ವೆಲಾಸಿಟಿ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್. ಸಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನ್ ಫಾರ್ಮುಲಾ? ಇ ನಾಟ್ ಬೈ ಬಿ ನಾಟ್. E naught by B naught. But he has given frequency. ಏನು ಕೊಟ್ಟಿದ್ದಾನೆ ಅವನಲ್ಲಿ? Frequency. How to introduce frequency? ಆಯ್ತಾ? You know mu is equal to C by lambda. You know B is equal to C by lambda. ಆಯ್ತಾ? ಅಥವಾ C can be written as mu into lambda. Mu into lambda. So what is the magnetic field vector at that point? What is the magnetic field? So C can be written as mu lambda is equal to E naught by B naught. So what is was asking for what is the magnetic field? ಅಗರ್ ಬಿ ನಾಟ್ ಎಷ್ಟಿರುತ್ತೆ? ಬಿ ನಾಟ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು ಇ ನಾಟ್ ಮ್ಯೂ ಇಂಟು ಲ್ಯಾಂಬ್ಡಾ. ಮ್ಯೂ ಇಂಟು ಲ್ಯಾಂಬ್ಡಾ. ಸೊ ಯು ಕ್ಯಾನ್ ಡೂ ಇಟ್. ಆಯ್ತಾ? ಮಾಡಿ ಇದು. ವಾಟ್ ಇಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವೆಕ್ಟರ್ ಅಟ್ ದಟ್ ಪಾಯಿಂಟ್? ಅಗರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟಿರುತ್ತೆ ಅಂತ. ಇಟ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವೆಕ್ಟರ್ ಅಟ್ ದಟ್ ಪಾಯಿಂಟ್. ವಾಟ್ ಇಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವೆಕ್ಟರ್ ಅಟ್ ದಟ್ ಪಾಯಿಂಟ್? ಸೊ ಏನು ಕೊಟ್ಟಿದೆ? ಗಿವನ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಇಟ್ ಈಸ್ ಟ್ರಾವೆಲಿಂಗ್ ಅಲಾಂಗ್ ದ x direction. It is traveling along the x direction. So what is the magnetic field vector at that point? Magnetic field vector ಎಷ್ಟಿದೆ? What is the magnetic field vector at that point? Magnetic field vector at that point. Try ಮಾಡಿ ನೋಡೋಣ. What is the magnetic field vector at this point? B not calculate ನೋಡಿ. Just given frequency, a plain electromagnetic wave frequency 20 megahertz travel through a space along x direction. If the electric field vector at that certain point is 6 volt per meter, electric field 6 volt per meter ಇದೆ. What is the magnetic field? It's asking for magnetic field. How to calculate the magnetic field? Mu C is equal to E naught by B naught, ಅಥವಾ mu is equal to C by lambda. So ಮಾಡಿ ನೋಡಿ. ಆಯ್ತಾ? Shall take some time. So the next thing is electromagnetic radiation used to sterilize milk is. Which electromagnetic radiation used to sterilize the milk? ಇದರಲ್ಲಿ ಯಾವ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಟಿಕ್ ರೇಡಿಯೇಷನ್ ನೀನು ಸ್ಟೆರ್ಲೈಸ್ ಮಾಡಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀಯ ಅಂತ. ಸ್ಟೆರ್ಲೈಸ್ ದ ಮಿಲ್ಕ್. ಸೊ ಆನ್ಸರ್ ಇಸ್ UV rays. UV rays. ಯಾಕಂದ್ರೆ UV treated ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ UV rays are used to sterilize the milk. Which rays? UV rays are used to sterilize the milk. Correct. The next question is, ನೋಡಿ, an electromagnetic wave is traveling in the x direction. ಒಂದು electromagnetic wave ಇದೆ, it is traveling in the x direction with electric field vector given by E is equal to E naught sin kx minus omega t. E naught sin kx minus omega t. The correct expression for magnetic field vector is, what is the correct expression for magnetic field vector? ಇದರಲ್ಲಿ magnetic field vector ಗೆ ಏನು correct expression ಅಂತ ಕೇಳಿದಾನೆ. What is the correct expression for magnetic field vector? Which vector? Magnetic field vector. Magnetic field vector. So an electromagnetic wave is traveling in which direction? X direction with electric field vector given by, this is the electric field vector. What is the electric field vector is given? E is equal to E naught sin kx minus omega t into j cap. So it is the electric field vector. Andre in which direction? Since it is j cap, it is traveling along y direction. The correct expression for the magnetic field vector is, what is the correct expression for magnetic field vector? So in which direction the electromagnetic wave is traveling? Since it is traveling along x direction, electric field is along y direction. So the magnetic field should be along z direction. So it should be along z direction. So BZ. ಎಲ್ಲರಿಗೂ BZ ಇಲ್ಲ. ಆಪ್ಷನ್ 3 ಮತ್ತೆ ಆಪ್ಷನ್ 4 ನಲ್ಲಿ BZ ಇದೆ. So you can remove the option 1 ಮತ್ತೆ ಆಪ್ಷನ್ 2 ನ ತೆಗಿಬಹುದು. ಯಾಕಂದ್ರೆ magnetic field should be along z axis. So BZ is equal to answer B naught sin same thing kx minus omega t. So into z direction ಇದೆ. So it should be I j k k cap. It should be k cap. ಇದು ಆಪ್ಷನ್, ಇದು ಆಪ್ಷನ್ ಇಲ್ಲ. ಆಯ್ತಾ? ಯಾಕಂದ್ರೆ ನೋಡಿ BY ಇದೆ, ಇಲ್ಲಿ ಇದೋಯ್ತು. ಸೊ ಹಾಗಾದ್ರೆ ಇವೆರಡಲ್ಲಿ ಆಪ್ಷನ್ 3 ಮತ್ತೆ 4 ಯಾವ್ದು ಆಪ್ಷನ್ ಇರುತ್ತೆ. ಸೊ BZ ಇಸ್ ಕರೆಕ್ಟ್, ಇಲ್ಲೂ BZ ಇಸ್ ಕರೆಕ್ಟ್. ಸೊ ಇಲ್ಲಿ B ನಾಟ್ ಇದೆ, ಬಟ್ ಇಲ್ಲಿ E ನಾಟ್ ಬೈ ಸಿ, E ನಾಟ್ ಇಂಟು ಸಿ ಇದೆ. ಬಟ್ ವಿ ನೋ ಸಿ ಇಸ್ ಈಕ್ವಲ್ ಟು E ನಾಟ್ ಬೈ B ನಾಟ್. ಸೊ ದೇರ್ ಫಾರ್ ವಿ ಕ್ಯಾನ್ ರೈಟ್ B ನಾಟ್ ಕ್ಯಾನ್ ರಿಟರ್ನ್ ಎಸ್ B ನಾಟ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು E ನಾಟ್ ಬೈ ಸಿ. ಸೊ ದೇರ್ ಫಾರ್ BZ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು, ಬಿಟ್ಬಿಡೋಣ ಇಲ್ಲಿ, B ನಾಟ್ ಬದಲು ಯು ಕ್ಯಾನ್ ರೈಟ್ ಎಸ್ E ನಾಟ್ ಬೈ ಸಿ sin kx minus omega t into k cap. Omega t into k cap. So option is C. Third one. Option third is correct. So that is the correct option. That is the correct option. So the correct option is third one. BZ is equal to E naught by C sin kx minus omega t into k cap. Omega t into k cap. The next question. Suppose that the electric field amplitude of the electromagnetic wave is, he has given the electric field vector code. Next day, how much is the electric field? E naught is equal to 120 Newton per Coulomb and its frequency is 20 megahertz. Then which of the following value is incorrectly computed? Agar idರಲ್ಲಿ incorrect ಆಗಿ ಕಂಪ್ಯೂಟ್ ಆಗಿರೋದು ಯಾವುದು ಅಂತ ಕೇಳಿದಾನೆ. Which of the following is incorrectly computed? Which of the following is incorrectly computed? Try ಮಾಡಿ ನೋಡೋಣ. Suppose that the electric field amplitude of the electromagnetic wave is E naught. He has given E naught. ಏನು ಕೊಟ್ಟಿದ್ದಾನೆ ಅವನು? E naught ಕೊಟ್ಟಿದ್ದಾನೆ. E naught is 120 Newton per Coulomb. 120 Newton per Coulomb. And its frequency of the electromagnetic wave F ಕೊಟ್ಟಿದ್ದಾನೆ. F is equal to 50 megahertz. 50 megahertz. Then which of the following value is incorrectly computed? Idರಲ್ಲಿ he has calculated 4 physical quantities. ಇದರಲ್ಲಿ ಯಾವುದು ರಾಂಗ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದೀನಿ ಅಂತ ಕೇಳ್ತೇನೆ. Suppose that the electric field amplitude of the electromagnetic wave is electric field component. So frequency ಕೊಟ್ಟಿದ್ದಾನೆ. ಇದರಲ್ಲಿ ಯಾವ್ದು ರಾಂಗ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದಾನೆ? Wrongly calculated. First he has calculated the magnetic field. Magnetic field amplitude is 400 nano Tesla ಅಂತ ಹೇಳ್ತೇನೆ. How to calculate the magnetic field? How to calculate the magnetic field? You can use the same formula. ಆಯ್ತಾ? So what is the formula? C is equal to E naught by B naught. So therefore B naught will be equal to E naught by C. E naught by C. So how much is E naught? 120 Newton per Coulomb divided by C is 3 into 10 power of 8 meter per second. So it will be equal to 3 ones are 40. 3 fours are 40 into 10 power of minus 8 Tesla. Correct? This can also be written as 400 mana. Make it as 400. It becomes 10 power of minus 9 Tesla. So this will be equal to 400 nano Tesla. Nano Tesla. So this is correct. The calculation is correct. On incorrectly calculated. Next angular frequency of electromagnetic wave is. ಈ electromagnetic wave angular frequency omega ಎಷ್ಟಿದೆ ಅಂತ ಹೇಳ್ತೇನೆ 5 into 10 power of 8. So it's telling that omega is equal to 5 into 10 power of 8 radian per second ಅಂತ ಹೇಳ್ತಿದ್ದಾನೆ. Radian per second. So omega we should calculate. We calculate the omega. How to calculate omega? By this frequency f. You know, omega is equal to 2 pi by 2. That is also equal to 2 pi into f. 2 pi into f. So that is equal to 2 into pi is 3.14. How much is frequency? Frequency. But I can pi it, but no need of substituting pi. So ಇಲ್ಲಿ pi na substitute ಮಾಡೋ necessity ಇಲ್ಲ. So it will be 2 pi. That will be. So 2 into pi into frequencies. How much is frequency? 50. 50 mega under 10 power of 6 hertz. ಎಷ್ಟಾಗುತ್ತೆ ಇದು? 5 to the 10 100 ಆಗುತ್ತೆ ಆಯ್ತಾ? It will be pi into 100. 100 ಅಂದ್ರೆ 10 power of 8. 10 power of 8. So pi into 10 power of 8 radian per second ಅಂತ ಹೇಳಿದ್ರೆ omega SI unit is radian per second. So the correct option. So correct option ಅಲ್ಲ, the calculation is correct. So second calculation is also correct. So omega is calculated is also correct. Next ಕೇಳ್ತಾ ಇದ್ದಾನೆ third one. ನಾವು ಮಾಡ್ಬೇಕಾದ್ರೆ you have to find the wrong. Following is incorrectly computed. So first correct calculate ಮಾಡಿದ್ದಾನೆ. Second angular frequency correct calculate ಮಾಡಿದ್ದಾನೆ. Third one propagation constant. The constant propagation constants. You know what is propagation constant? Propagation constant k. K is called as a propagation constant. So k calculate ಮಾಡಕ್ಕೆ k is formula 2 pi by lambda. 2 pi by lambda. So how to calculate propagation constant? 2 pi by lambda. ಅಥವಾ we know another formula. C is equal to omega by k. C is equal to omega by k. ಇದರಿಂದ you can calculate k. K is equal to omega by c. How much is omega? Just we have calculated. It is pi into 10 power of 8 radian per second. Then divide by c, 3 into 10 power of 8 meter per second. So 3 ಮತ್ತೆ pi almost they are equal. They are equal. So idna you can make it as 1. 10 power of 8, 10 power of 8 cancel. So k comes out to be 1. K comes out to be 1. But on propagation constant 2.1 ಅಂತ ಹೇಳ್ತೇನೆ. So it is wrong calculation. Wavelength of the electromagnetic wave. How to calculate the wavelength of the electromagnetic wave? How to calculate the wavelength of the electromagnetic wave? So you can use the formula mu is equal to c by lambda. So lambda is equal to c by mu. How much is c? 3 into 10 power of 8. How much is mu? Frequency 50. 50 megahertz 10 power of 6 ಆಯ್ತಾ. ಸೊ ಇಟ್ ಕಮ್ಸ್ ಔಟ್ ಟು ಬಿ 6 ಮೀಟರ್ ಆಯ್ತಾ. ಸೊ ಇದನ್ನ 3 ನ ಏನ್ ಮಾಡಿ ಇದನ್ನ ಮೇಕ್ ಇಟ್ ಸಮ್ 8 ಅಲ್ಲಿ 2 ತಗೊಂಡು ಇಟ್ ಬಿಕಮ್ಸ್ 300 ಡಿವೈಡ್ ಬೈ 50 ಇಂಟು 10 ಪವರ್ ಆಫ್ 6 ಇರುತ್ತೆ. 10 ಪವರ್ ಆಫ್ 6 ಇಲ್ಲಿ ಕ್ಯಾನ್ಸಲ್. ಸೊ 5 ones of 0 0 cancel, 5 ones of 5 6. So it comes out to 6 meter. 6 meter. So therefore, wavelength of the electromagnetic wave is also correctly calculated 6 meters. So agar wrong calculation ಮಾಡಿರೋದು ಯಾವ್ದವನು propagation constant. Propagation constant is wrongly calculated. 2.1 ರೇಡಿಯನ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಂತ ಹೇಳ್ತೇನೆ. ದಟ್ ಈಸ್ ಆಂಗ್ಯುಲರ್ ವೇವ್ ನಂಬರ್. ಆಮೇಲೆ ಯೂನಿಟ್ ನೋಡೇ ತಪ್ಪು ಅಂತ ಹೇಳೋದಿರ್ತೇನೆ. ರೇಡಿಯನ್ ಪರ್ ಮೀಟರ್ ಕರೆಕ್ಟ್ ಇದೆ. ಯೂನಿಟ್ ಕರೆಕ್ಟ್ ಇದೆ. ರೇಡಿಯನ್ ಪರ್ ಮೀಟರ್ ಯಾಕಂದ್ರೆ 2π ರೇಡಿಯನ್, ವೇವ್ಲೆಂತ್ಗೆ ಲ್ಯಾಂಬ್ಡಾ. ಸೊ ರೇಡಿಯನ್ ಪರ್ ಮೀಟರ್ ಯೂನಿಟ್ ಈಸ್ ಕರೆಕ್ಟ್, ಬಟ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಶುಡ್ ಬಿ ಸಮ್ 1 ಬರಬೇಕಿತ್ತು. ಸೊ ಅವನು 2.1 ಇಟ್ಟಿದೆ. ಸೊ ದೇರ್ ಫೋರ್ ಆಪ್ಷನ್ 3 ದಟ್ ಈಸ್ ರಾಂಗ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ಸೊ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಈಸ್ 3. ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಈಸ್ 3 ವಿಚ್ ಈಸ್ ರಾಂಗ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ರಾಂಗ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟೆಡ್. ದ ನೆಕ್ಸ್ಟ್ ಥಿಂಗ್ ಈಸ್ the source of the electromagnetic wave can be. Which of the following can be the source of the electromagnetic wave? ಇದರಲ್ಲಿ ನಿಮಗೆ ಗೊತ್ತು electromagnetic waves can be produced. Electromagnetic waves can be produced by oscillating charges ಅಥವಾ accelerated charges. ಎಂತ charges? Oscillating or accelerated charges. 1 minute. choose ಮಾಡೋಣ. Oscillating or accelerated charges. Accelerated charges, they are the main source of electromagnetic waves. So agar one question, and what is the question? The source of electromagnetic wave is clearly which of the following is the source of electromagnetic wave? Which of the following is source of electromagnetic wave? Electromagnetic wave is source ಯಾವುದು ಅಂತ ಕೇಳಿದೆ. Which of the following is source of electromagnetic wave? Option is a moving charge with constant velocity. Wrong. So ಯಾಕಂದ್ರೆ constant velocity ಇದ್ರೆ you cannot produce the electromagnetic wave. So this is wrong. Moving in a circular orbit, a charge, say an electron, which is moving in a circular orbit, can it produce the electromagnetic wave? Yes, it can produce the electromagnetic wave because it is continuously getting accelerated. It is continuously getting accelerated. So therefore, this is the accelerated charge which will produce the electromagnetic wave. Which will produce the electromagnetic wave. So that is the correct option. So the option is moving charge, moving in a circular orbit. Moving in a circular orbit. So next I have one question ಬಿಟ್ಟಿದ್ವಿ ಅಲ್ಲಿ. Which one you have left? Question number ಇದಲ್ಲ, ಮೋಸ್ಟ್ಲಿ ಇದು ಟ್ರೈ ಮಾಡಿ ನೋಡೋಣ. A plane electromagnetic wave of frequency 50 Hz. ಆಯ್ತಾ, find the answer. Try to get the answer. A plane electromagnetic wave of frequency ಕೊಟ್ಟಿದ್ದಾನೆ. ಏನೋ ಕನ್ಫ್ಯೂಸ್ ಆದ್ರು ಅಂತ ಇಲ್ಲಿ. ವೆದರ್ ಯಾವ ಕನ್ಫ್ಯೂಸ್. ಫ್ರೀಕ್ವೆನ್ಸಿ ಕೊಟ್ಟಿದ್ದಾನೆ. How much is the frequency? Frequency is 20 megahertz. 20 megahertz. Travels along x direction. If the electric field vector ಕೊಟ್ಟಿದ್ದಾನೆ. How much is electric field vector? 6 volt per meter. What is the magnetic field? ಅगर magnetic field ಎಷ್ಟು ಅಂತ ಕೇಳಿ. What is the magnetic field? ಸ್ಪೇಸ್. ನಾವು ಸುಮ್ಮನೆ ಕನ್ಫ್ಯೂಸ್ ಆಗಿದೆ ಇಲ್ಲಿ. ಸ್ಪೇಸ್ ಅಂತ ಹೇಳ್ಬಿಟ್ಟಿದೆ. ಸೊ ಸ್ಪೇಸ್ ಅಂದ್ರೆ ಇಟ್ ಮೂವ್ಸ್ ವಿತ್ ವೆಲಾಸಿಟಿ ಆಫ್ c is equal to 3 into 10 power of 8 meter per second. ನೋಡಿ, ಕನ್ಫ್ಯೂಸ್ ಮಾಡೋದಕ್ಕೆ ಎಸ್ ಗಿವನ್ ದಿಸ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಏನು ಕೆಲಸನೇ ಇಲ್ಲ ನಮಗೆ. ಯಾಕಂದ್ರೆ ವಿ ನೋ ಸಿ, ವಿ ನೋ ಇ, ವಿ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಬಿ ಅಷ್ಟೇ. c is equal to E naught by B naught. E naught by B naught. So therefore B naught ಅಥವಾ B naught will be equal to ಏನಾಗುತ್ತೆ? E naught by C. How much is E naught? How much is E naught? He has given 6 volt per meter. How much is C? 3 into 10 power of 8 meter per second. Meter per second. So it will be 3 ones are 3 twos are. So it will be 2 into 10 power of minus 8 Tesla. The correct option is 2. Second option is correct. Second option is correct. 2 into 10 power of minus 8 Tesla. ನೋಡಿ, we have got confused. ಯಾಕಂದ್ರೆ ನೋಡಿ, he has given frequency. ಈ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇದು ಅಲ್ಲಿ ನೆಸಿಟಿನೇ ಇಲ್ಲ. ಸೊ ಜಸ್ಟ್ ಟು ಕನ್ಫ್ಯೂಸ್ he has given frequency. ನಮಗೆ ಕನ್ಫ್ಯೂಸ್ ಮಾಡೋಕ್ಕೋಸ್ಕರ he has given frequency. ಸೊ ದೇರ್ ಫೋರ್ ಇಸ್ ಯೂಸ್ ಇಲ್ಲ. ಬಟ್ ನಾವು ಹುಷಾರಾಗಿರ್ಬೇಕು, ಆಯ್ತಾ. ಕನ್ಫ್ಯೂಸ್ ಮಾಡೋಕೆ he has given frequency. ನಾವೆಲ್ಲೂ ನೋಡಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಯೂಸೇ ಮಾಡಿಲ್ಲ. ಜಸ್ಟ್ ಸಿಂಪಲ್ ಫಾರ್ಮುಲಾ ಯು ಹ್ಯಾವ್ ಫೌಂಡ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎಷ್ಟಿದೆ? 2 into 10 power of minus 8 Tesla. So therefore the correct option is 2. Correct option is 2. So today we shall end. Tomorrow we shall solve some more problems tomorrow. So we can end the chapter electromagnetic waves tomorrow. So thank you for watching. Thank you.